Hi there. Here's the first video where I'm going to take you through the idea of what's called correlation. So before I give you the formula, R represents the correlation, and it measures only the strength of a linear relationship. So if we have a relationship that is curved, we can't use correlation to represent its strength. And it has to be the relationship between two quantitative variables. So variables which are numeric, we can't take correlation using categorical variables. So the next thing to observe is the correlation is a number. That number is between -1 and +1. It could be exactly -1 or exactly +1 if it is an exact linear relationship. That's something that we will explore on the back page in just a little bit. So the correlation R has no units. There's no unit of measurement here. Just like z-scores. Z-scores do not have units. Same thing with correlation, and that's actually because if you look carefully at the formula for correlation, it uses z-scores. So correlation is a sum, so there is our sigma notation, and it is the sum of the following. Two large sets of parentheses here. So for each xy ordered pair, we take x, we subtract the mean of x and divide by the standard deviation of x. So for the y value in that ordered pair, we take y, we subtract the mean of y and divide by the standard deviation of y. And those are multiplied together. But notice this is the z-score for x. This is the z-score for y. So every ordered pair has an x and a y value. So every ordered pair has a z-score for x, a z-score for y, and they are multiplied together. So this is done for all of the ordered pairs. They are added up, and then we take their average. But instead of dividing by n, because we're using standard deviations, we have to divide by n minus 1. So traditionally, we write that instead of division, we think of it as multiplying by 1 over the quantity n minus 1. That's the formula for correlation. So the reason why R has no units is, in fact, we are using z-scores to calculate the correlation, and these don't have units either. So let's calculate a correlation. Example 1. The correlation between the number of powerboat registrations, that's the list boat, and the number of manatee deaths, we called that manatee. So let me pull up my calculator and I'll show you how to do this. Okay, so first thing, something to think about. If we didn't do this in class today, it is very important that you turn on the command that will allow you to see the correlation calculation. So to do that, you need to press the second button, and then you need to press the 0 button. This brings up the catalog of all of the different commands that are on this calculator. It's very important that you do this first. So I'm going to scroll all the way through these, and I want to get to the commands that start with D. I could have just pressed D if I wanted to, but I'm going to scroll through anyway since I'm nearly there. So the command that I'm looking for is named diagnostic on. To my knowledge, there isn't another way to get to it in a different menu. My understanding is the only way to get to it, there it is by using the catalog. So here is the command diagnostic on. I'm going to put the little arrow next to it, and I'm going to press enter twice. The first time brings it to the home screen, and the second time actually executes the command. With diagnostics on, now I'm going to be able to actually calculate the correlation. So to do that, the first thing I need to do is to put my data into list 1 and list 2. So boats are the explanatory variable. So second stat button, I'm going to go and select the variable boat. There it is. I'm going to store that into list 1. That's my explanatory variable, and the number of manatee deaths is my response variable. So second stat, we'll go select M-A-N-T-E, manatee. There is it, there it is. I'm going to store that into list 2. Now, to calculate the correlation, you don't actually have to create a scatter plot, but quickly I'm just going to create the scatter plot anyway. So here's the second button, the y equals button. I can see that plot number 1 is on, so I'm going to go into that plot and set it up to be a scatter plot. So this is actually the scatter plot option, so I'm going to press enter to select it. And my data are in list 1 and list 2. The explanatory variable is in list 1. The response variable is in list 2. Looks good. So now I'm going to press zoom 9. So there is the scatter plot, just like we saw in class. So to create the correlation, though, we don't need the scatter plot. So just wanted to remind you that's how you do it. Let's go back to the home screen. To do the correlation, press the Stat button. Press the right arrow to select the Calc menu. So the option we're going to choose, you could choose option number 4. There is nothing wrong with that. That says linear regression. I am going to select option number 8. It is the same command. It's just in a slightly different order. I prefer option number 8. We'll talk more about that over the next couple of days. So if you press enter, what this is going to do, it is going to ask you for an X list and a Y list. So those are already list 1 and list 2. You don't need to enter anything else for any of the other commands. Simply press calculate, you're good to go. If you have an older model calculator, after you select this command, the command automatically chooses list 1 and list 2 to be the X and Y list. So you can just go ahead and execute the command on the home screen. So we will talk about more of this tomorrow. So we will talk about what the A and the B and the R squared represent. For now, the correlation is right here. It is plain R. The correlation for the manatee data is 0.94. That is a very high correlation. So that correlation is 0.94. Now understand, the correlation can't get any higher than 1. So we're already really close to 1. So this linear relationship is indeed strong because the value of R is very close to positive 1. This is a strong positive relationship. The closer we are to positive 1, the stronger this positive relationship. But it's very important. We have to be describing a linear relationship. That's why I wanted to do example 2 with you. So in this example, we're going to find the correlation between speed and the fuel consumed by this Ford Escort from the homework. So if you remember this scatter plot was curved. Let's actually go to the calculator. So I'm going to load the data that I need. So second stat, I'm going to load speed as my explanatory variable. So I'm going to load that into list 1. Where is it? There it is, speed. I'm going to store that into list 1. Then my response variable is fuel. That's the amount of fuel consumed per 100 kilometers. So we'll select that. There's fuel. So I'm going to store that as my response variable into list 2. So if we wanted to review what the scatter plot looks like, I can just hit zoom 9. So this is definitely not a linear pattern. This is definitely a curved pattern. Now, it is still strong. It is still a strong relationship. It follows that curve pretty closely. But because it's not a linear pattern, the correlation is going to have a low value. So here, again, Stat button. I'm going to go over to the Calculate menu, and I'm going to use option number 8. So you can scroll down to it and press Enter, or you can just press the 8. And again, my data are in list 1 and list 2, so I'm ready to calculate. We are expecting a low correlation, and indeed it is quite low. It is negative 0.17. So I'll be honest, this is a very weak relationship. At least the correlation suggests that it is a weak relationship, but it would only be weak if we were looking at a linear relationship. So understand, the correlation in this context is not particularly useful. The correlation is negative 0.17. So even though the relationship is very strong, it is a very strong relationship, it's not linear. So it exhibits a very weak correlation with a value of R that's close to 0. Correlation is only appropriate when we are describing relationships that are linear. If it is not linear, if it's clearly curved, then calculating R and using it to describe the strength of the relationship is inappropriate. So a few more things about R. So correlation does not distinguish between explanatory and response variables. Explanatory and response variables. So notice the reason this is the case is because we are multiplying. It doesn't matter whether x comes first or y comes first. We're simply taking the z-score for x and the z-score for y and we're multiplying them together. You can multiply together in any order you like, so it really doesn't matter if you're just calculating the correlation, whether x is the explanatory and the response variable and whether y is the explanatory of the response variable. It really doesn't matter. It matters certainly when we're describing the relationship or thinking about the relationship or the scatter plot, but strictly for this calculation, because we're multiplying these z-scores together, it doesn't matter. So as you can guess then, if R is greater than 0, so if the correlation is positive, this indicates a positive association. If R is less than 0, this indicates a negative association. So something else to think about, we are multiplying z-scores together. So z-scores are linear transformations of the data. So understand that if we change the units of measurement, changing the units of measurement has no effect on R. So changing units of measurement has no effect whatsoever. So for instance, if we have data that are in terms of inches, changing those data to be in terms of centimeters will not affect the correlation whatsoever. So last up, this is where we're going to start in the next video. I'm going to break right here for just a minute. So we're going to look at what outliers might do to R, to the correlation. We've at least finished the basics of correlation. Click on the next video and we'll keep going.